My name is Muhammad Ali Amidi. Today we are going to talk about 5G numerology and radio frame structure in 5G NR technology. Please like and subscribe our YouTube channel if you like this presentation. Thank you so much. First of all, we are going to discuss about what is the meaning of numerology. Actually, numerology defines the frequency domain subcarrier spacing. So the meaning of numerology will be subcarrier spacing. As far as 3GP is the main concern in 5G technology, 3GPP TS38.211 specified the subcarrier spacing of different numerology, 5 types of different numerology like 15, 30, 60, 120, and 240 kHz. Subcarrier spacing determines the frequency domain band and the time domain duration of a single resource element. The final point is the resource element has dimension of one subcarrier in the frequency domain and one symbol in the time domain. These figures are showing resource element dimension for 15 and 30 kHz subcarrier spacing. These figures illustrate the dimension of a resource element is equal to the subcarrier spacing. Increasing the subcarrier spacing by a factor of 2 increase the resource element bandwidth by a factor of 2. So the time domain of the resource element, excluding the cyclic prefix, is equal to 1 divided by 15, which is 0.067 millisecond when using the 15 kHz subcarrier spacing. So increasing the subcarrier spacing by a factor of 2, it will decrease the resource element duration by a factor of 2. The time domain duration of a resource element is equal to one cycle of sine wave with a frequency equal to subcarrier spacing. A single resource element can accommodate a single modulation symbol. For example, the single resource element could be used to transmit a single QPSK 16 QAM, 64 QAM, 256 QAM modulation symbol. A QPSK symbol represents 2 bits of information, so the capacity of resource element corresponds to 2 bits when transferring a QPSK symbol. A 256 QAM symbol represents 8 bits of information, so the capacity of a resource element corresponds to 8 bits when transferring a 256 QAM symbol. To use of multiple subcarrier in the frequency domain and a multiple symbol in a time domain generates a grade of resource elements. Resource elements grade generated by frequency domain subcarrier and a time domain symbol, which shows the resource elements grade for 30 kHz subcarrier spacing in this chart, in this figure. The lowest row of resource element within this figure uses a subcarrier frequency of 30 kHz, while the row above uses a subcarrier frequency of 60 kHz, and the row above that uses a subcarrier frequency of 90 kHz. The subcarriers are modulated and summed at the transmitter when generating the air interface waveform. The modulation and summing of subcarrier corresponds to an inverse fast Fourier transform, IFFT. A combination of numerologies can be used within a duration of a single symbol. For example, the subcarrier spacing of 15 and 30 kHz can be combined when generating the air interface waveform. The concept of combining multiple numerologies is shown in this figure. 3GPP has specified which numerology can be used within each operating band. This means only a specific numerology combination are permitted. The 15 and 30 kHz subcarrier spacing can be combined, but 15 and 120 kHz subcarrier spacing cannot be combined. Now let's discuss about deployment scenario with multiple numerology. First of all, deployment scenario with larger propagation channel delay spurt use lower subcarrier spacing to benefit from longer symbol and longer cyclic prefix durations. Longer cyclic prefix duration are able to accommodate a large delay spurts. Delay spurts are typically larger for macro cell deployments with relatively large cell range. This means that the lower operating band with their lower air interface propagation losses and larger cell range benefits from using the lower operating bands with their lower air interface propagation losses and larger cell range benefit from using the lower subcarrier spacing. So we can say the higher operating bands with their higher air interface propagation losses and smaller cell ranges can use the higher subcarrier spacing. Deployments using the higher operating bands suffer from increased oscillator phase noise, which cause a random jitter in the phase of receiver signal. Higher subcarrier spacing are more robust against this jitter because the magnitude of the jitter is relatively small when compared to magnitude of the subcarrier spacing. Deployment scenarios with a high mobility like high speed train scenarios experience high Doppler frequency offset. As you are aware, even we had this one in 4G as well, this Doppler frequency offset. Higher subcarrier spacing are more robust against this offset because the magnitude of the offset is relatively small when compared to the magnitude of the subcarrier spacing. And finally, end user application with the low latency requirements benefit from short symbol duration. For example, high subcarrier spacing. The short symbol duration allow data to be transmitted and acknowledged with minimal delay. So this is the deployment scenario with multiple numerology, and we are using the different numerologies in 5G technologies. Here I wanted to say in comparing to the LT numerology, subcarrier spacing and symbol length, the most outstanding difference you can notice is that NR supports multiple different type of subcarrier spacing as I said. As you see here, each numerology is labeled as a parameter here, as a parameter mu. The numerology mu is equal to 0 represent 15 kilohertz, which is same as LT technology, current LT technology. And as you can see in this the second column, in the second column, the subcarrier spacing of other mu is derived from mu is equal to 0 by scaling up in the power of 2. So you can see when you have the 15 kilohertz subcarrier spacing and your mu is equal to 0, your PRB will be 180 kilohertz. We have same for mu is equal to 1, your subcarrier spacing will be 30 kilohertz and your cyclic prefix type will be normal. And in this case you will have same 12 subcarrier spacing, which is 30 multiplied by 12 will be 360 kilohertz your PRB. We have same when you have mu is equal to 2, you will have the 60 kilohertz subcarrier spacing, which your type will be normal and extend. Just in mu is equal to 2, you will have both type of cyclic prefix normal and extended. In this case your PRB will be 720 kilohertz. And when your mu is equal to 3, your subcarrier spacing will be 120 and your PRB will be 1440 kilohertz. And finally, with the mu is equal to 4, your subcarrier spacing will be 240 and your cycle period will be normal and your PRB length will be 2880 kilohertz. Slot lengths get different depending on numerology. The general tendency is that slot length gets shorter as the subcarrier spacing gets wider. Actually, this tendency comes from the nature of OFDMA. As you can see in this table, when your mu is equal to 0, your subcarrier spacing 50 kilohertz and your time length will be 1 millisecond. And for the 30 kilohertz, your time will be 0.5 millisecond. For the 60 kilohertz, your time will be 0.25 millisecond. For the 120 kilohertz, your time will be 0.125 millisecond. And finally, with mu is equal to 4 or 240 kilohertz subcarrier spacing, your time slot length will be 0.0625. And now we are going to talk after numerology about the radio frame structure. In a LT, as you remember, we had the frame 10 millisecond. Each frame, it will be 10 subframe, and each subframe will be 1 millisecond. Each subframe will be divided by 2 time slot, and time slot, as we said, is fixed and 0.5 millisecond. And it will be divided by the 7 or 6 OFDMA symbol according to your type of OFDMA, according to your type of cyclic prefix. This is the radio frame structure in the 5G. We are going to show you when you have the normal CP, your numerology is equal to 0. In this configuration, a subframe has only 1 slot in it. It means a radio frame contains 10 slots in it. The number of OFDMA symbols within a slot is always 14. For example, see here you have one frame. It always will be 10 milliseconds. It will divide it to 1 subframe and 1 slot, and each slot it will contain 14 symbols. As described in 5GNR, multiple numerology are supported, and the radio frame structure gets a little bit different depending on the type of the numerology. However, regardless of numerology, the length of one radio frame and the length of one subframe is same. The length of a radio frame is always 10 milliseconds, and the length of the subframe is always 1 millisecond. So what should be the different to accommodate the physical property of the different numerology? The answer is to put a different number of slots within one subframe. There is another varying parameter with numerology. It is the number of symbols within a slot. However, the number of symbols within a slot does not change with the numerology. It's only changed with the slot configuration type. For slot configuration 0, the number of symbols for a slot is always 13, and for the configuration 1, the number of symbols for a slot is always 7. Here it's showing when your numerology is equal to 1. So you can see it is the fix. You will have one frame, 10 milliseconds, but it is 20 slots. So your one subframe, it will divide it by 2 slots, and your time length is changed to 0.5 millisecond, and each slot will have contain 14 symbols. Same when you have 2 numerology, you will have 4 slots, and in each slot you will have 14 symbols, and so your time slot length changed to 0.25 milliseconds. This is different between the LT and 5G. As we showed before, in LT your time slot length always fixed, and it was 0.5 millisecond. And when your numerology is 3, again your radio frame, it will contain 10 subframe and 10 millisecond, but your subframe, it will divide it by 8 slots in a 1 millisecond. So time slot length, it will be 0.125 millisecond, which is contained 14 of. Thank you so much for your consideration.